All right, now that you got some practice last section about looking at some graphs and being able to just look at the graph and see what type of transformation have been changed, now we want to learn about how we just look at a function and make some changes based on doing some transformations numerically to those functions and understanding what that change is going to do between translations, reflections, and vertical stretching and shrinking. So in this first example, we're going to look at a linear function and see how we make some changes by translating, and we want to see what we have to do to this function to get this desired result. So before we do that, let's go ahead. We've got our journal here, and in it, if we look at the first core concept, we look at what we have to do to our function to create horizontal and vertical translations. Now remember, horizontal translations move the graph left and right. Vertical moves it up and down. So first, let's look at a horizontal translation. Now, here we've got our general graph, and what we're going to do is see how we change our function to cause a horizontal translation. Now, here we're told that if we make this change, if we turn f of x into f of x minus h, that's going to cause a horizontal translation. Now, what that does, remember, h is just a number. Now, remember, x is the input to our function. So when we have f of x, remember, whatever value we put inside here, that's the value we put in as our variable to evaluate our function. So what this means, f of x minus h, that means if we substitute a value from whatever our input is supposed to be, that's going to move our graph left and right. So subtracting a number from the inputs before evaluating the function shift the graph left and right. Okay, remember, this is subtracting a number from the input. Now that's important to remember because in this graph, we're going to have to do a translation 2 units down at some point. So in order to do that, we have to subtract h from our input. So you're going to see what that looks like in just a second. Vertical translations, that's when we add a number to our entire function. So you'll see that if we take a value k and add it to our function, that's going to move our function, our graph, up or down, which is a vertical translation. So let's go ahead and look at this. So here's our function, 2x plus 1. We want to write a new function whose graph is a translation 3 units down from the graph of f. So let's just remember for a second. If we have a graph of 2x plus 1, what that means is that 2x plus 1 means that we have an x-intercept at 1, and we have a slope of 2, which means that for every 2 units up, we go 1 unit over. So again, if we do 2 units up, we go 1 unit over. Okay, so this is kind of a steeper graph right here. It's steeper than our parent function. So we want to write a function that translates 3 units down. So that means we want a function that looks like this. Okay, I know this is kind of a crude drawing, but we want it to go 3 units down. So that's what our translation is going to do. It's going to take this graph and move it 3 units down from what our original function is. Okay, so remember, to move 3 units down, which is a vertical translation, we need to subtract 3 from our entire function. Okay, so down, we're subtracting from our function to move down. So let's go ahead and look at what that means. So the easiest way to do this I always find that it's best to write our function in terms of f of x still. Okay, so let's go ahead, translation 3 units down, we're adding -3, so we're subtracting 3. So let's go ahead, and our new function is just going to be our original function minus 3. We're adding -3. So the way that you can get your new function, you first of all write your transformation out. So with whatever change you're going to make, leave your original function in function form, and then you go ahead and simplify this. So now we can go ahead and we can replace f of x with whatever our original function was, and we can go ahead and simplify things now. So we substituted our original function for f. Now we go ahead and simplify this transformation. So right here we've got +1 plus -3, which is just -3. So now 1 minus 3 is -2. So now we get 2x minus 2. And if we go ahead and graph that, you'll see that that's our change. Remember, all we did when we looked at that graph was just move down to -2. We went from a y-intercept of 1 to a y-intercept of -2, and our slope stayed the same. And that's how we moved down 3 units. If you look at this graph, we went from a y-intercept of 1 to a y-intercept of -2. That's down 3 units, and our slope stayed the same. So it's actually pretty simple. The thing that really helps is when you're making this new transformed function is making sure that you first leave your new function in terms of f while you make your change, and then substitute the original value for f of x. Okay, now let's go ahead and look at how we do a translation 2 units to the left. So if we go here, again, we look at horizontal transformation, so we want to go to the left. And here, we have to go ahead and we have to subtract whatever our h value is from our input. Now you're going to see what that looks like here. It's sometimes hard to grasp this. So we're going to subtract -2. Because we're moving to the left, which is negative in our x value, we're subtracting -2. So here's where you really need to pay attention to your signs, otherwise it gets a little confusing. So let's go ahead and we're going to write our original function first. But remember, we are taking our input, which is x, and we're subtracting -2 from it. Okay, this right here might be a little confusing, but remember, our transformation is x minus whatever our translation is. So translation to the left is -2, and we have to take that value and substitute it from our input. Okay, now look what happens next. So we go ahead and we have to, you take this input value right here and you simplify. Remember, minus a negative turns this into a positive. So really what you have is subtracting a -2 is really adding 2 to the input. Okay, so let's look at what that means. So remember, our original function is f of x equals 2 of x plus 1. So that just means we're taking our input, multiplying it by 2, and adding 1. So here, if we change our input to x plus 2, that means whatever value of x we're trying to solve for, we're taking it and adding 2 before we evaluate this function. So let's look at what that looks like. Now, we have to go ahead and we write out our original function. But everywhere we have x, we are going to substitute x plus 2 for that. Because remember, we figured out that a translation 2 units to the left is taking our input, subtracting -2, which really is x plus 2, and we're replacing our input with that value. So that's what we're doing. We're replacing x with x plus 2. So that's the difference between changing the input, which is changing your x value, and changing the output, which is changing your entire function. So now you go ahead and simplify this. So we have to go ahead and distribute the 2, so 2x plus 4. So we go ahead and distribute that, so we get 2x plus 4, and then we add 1. So now our new function becomes 2x plus 5. So if we look at that, what we've done is we've taken our y-intercept, and we've changed that from 1 to 5. So from 1 to 5, that's moving to the left. Okay, that's our second change. And our first change is moving it down 3 units. So you can see how those changes are here in this graph. Okay, so this is the first time you've really looked at this, so the explanation is a little longer right here. So what I want you guys to do right now, in the text box that comes up, I want you to go ahead and you're just doing the same thing that we just did. So here's your original function, 4x minus 9, and you're going to be doing 2 parts. You're going to be writing a function whose graph is a translation 5 units up, and writing a function h whose graph is a translation 1 unit to the right. Okay, so you're going to have 2 new functions, g and h, whose graph is 5 units up and 5 units to the right. So what you should be writing in your text box, it should be 2 new functions, g of x equals and h of x equals. And they should be new functions that are linear, that have the proper changes made to them to reflect these translations. Now, if you have any questions about this, you should have them in your notes that you just took, or you can just take this video and rewind it a little bit and see again how we did those problems, because this is literally exactly the same problem, but all that's changed are these values that we're doing. So go ahead, give these a shot, and enter them into the text box.